You guys are muted, but okay, cool. Thanks. All right. So here, I'll share my screen. We can take a look at the agenda together. So we got a couple items on the agenda today. Looks like no action items from last time. So first up is the external resource provider design. This must have been Chun Hung. I'm pretty excited about this design moving forward. So thanks for putting it on the agenda, Chun Hung. Would you like to take it away?
Sure. Let me share my screen.
Okay, I will stop sharing. Go for it.
Can you guys hear us?
Sorry for the pun, but I put up a design doc for external resource provider, and so this document is actually a long doc because it actually a huge change to for Mesos. And this stuff laid out the general design for external resource provider, and also talk about also talk about a specific design for the SCRP. I'm not sure what you serve, like storage external resource provider, which is backed by CSI. So the goal is we want to use this new concept of resource provider to manage cluster-wide resources such as EBS volumes or other resources that is not tied to a particular agent. So when we use the resource, but we still want exclusive usage. That means we want to offer the resource to a certain framework, and that the framework launch a task, and while the task is running, no other frameworks can use those resources. But this is currently not doable because we only manage agent local resources for now, and all the support we have for such external resources are like out of band. So frameworks need to make sure that they don't launch two tasks that mount the same volumes to different nodes together. Otherwise, there will be some error or something. And so the concept of external resource provider is we want to also manage those resources that are external to agents in Mesos and grant exclusive usage for frameworks. And one important use is basically EBS volumes. And also in the future, we might want to support like TPUs. Another use could be like IP pools of IPs, but basically this concept is widely applicable to arbitrary cluster-wide custom resources. And the architecture will look like this. So specifically, because the first thing we want to support for external resources is probably the storage resource, EBS volumes or under the storage backend. So the design will be like this. So first, let me bring a little bit background. When we use such external resource like external EBS volumes, you need to first attach that particular volume to some agent before we are going to launch a task that use those agents. So you need, say, for example, take the EBS volume as an example, you need to, if you want to use the EBS volume out of band, you need to use AWS CLI to tell AWS to attach the EBS volume to a particular node. Then on that node, that device will show up as a block device, like /dev/xd whatever, xv whatever, and then you need to, on that node, before you can run a task consuming that volume, you need to do a mount to bring that volume into the host file system. And then after that, you can launch a container that mount that mounted EBS volume into the container's root FS and use it. So in CSI to accomplish this, we have CSI defines two components. One is called a controller plugin, which is like issue commands to AWS CLI to ask them to attach the device. And one is a node plugin, which will do the node we call it publish on nodes, which do a mount to bring the resource actually on the agent file system. So to use these two components, we also we will have in the SERP design, we have a controller and a publisher. So it's similar. It's kind of a match to what the CSS controller plugin node plugin. The controller manages resource. We can create volumes. We can remove, delete volumes. We can reserve, or we can attach, which is a new operation I'll talk about later. And the publisher will do the client agent side thing like mount. So apparently the controller need to be HA, and to support HA, well, it's a little hard. I feel it's a little bit too complicated just to have native HA support in Mesos. It doesn't sound like a Mesos job. So the design here is the operator can launch the SERP controller and the CSI controller plugin in a pod. You can launch it. The operator can launch it through systemd running on agent, or you can use some other frameworks to maintain the HA high availability for this pod. And the SRP will actively connect to the master, register the resource provider, provide its resource provider information. Then the master, when someone wants to use, will offer the resource out, and when someone wants to use the resource, it will talk to the master agents, which will use the publisher to mount the volumes. So,
Chen, so a quick question.
Sure.
For maybe some people might be curious about
so
the SERP controller and the CSI controller plugin, they're running in the same pod.
Yeah.
So are they running on each of the agent?
No. So it will be super hard if you want to run it, because so all the controller need to have a consistent view of how the resource is being used, how they are how the volumes are created, and how they are reserved. So we need a way to have a persistent global view of these external resources. So we cannot run this on every single agent. Otherwise, it will be a huge overhead to maintain a quorum for that global view.
So we're gonna only run one of them.
Yeah, we're going to run one of them on one agent. We need to run this thing on an agent because it runs a container to run the control plugin, and we cannot do that on master.
So is it Mesos master's responsibility to make sure if the controller die, it will launch another one?
So in the design, as I just said, I try to make the Mesos design simplify the design. So currently we don't have any mechanism in Mesos to ensure this life cycle HA in Mesos other than Mesos itself. So I'm relying on the operator to use another framework to maintain HA. For example, we can use Marathon, or you can use Aurora, or other frameworks that's appropriate for monitoring lifecycle of low-volume jobs.
So so let's say if we don't have HA, so sorry to interrupt, so we won't take too long. So let's say if we don't have HA and SDSI controller plugin, the whole part crash, and we still expect the agent with the external resources to they could work correctly, but we cannot adding more external resources in this case.
Well, if it lost connection, the master detect is disconnected, we will like we won't continue to offer the resources from the resource provider.
Okay, but for the existing, they will not be affected.
For those one that are already mounted and test is consuming it, it should be working. But after we recover it, like after the test finish it and return it to the masters, it will figure out, oh, actually this resource provider no longer exists. I cannot, it's unsafe to come and offer this offer out.
Okay. The last question is this stateless?
No, this one needs to be stateful.
Okay.
And yeah, so we need to be backed by a persistent store. So we need like a framework to provide HA for this part, and also it need to be able to access some persistent store to recover the state once it fail over.
So
yeah,
okay. Makes sense.
Yeah.
Yeah. Sorry to interrupt.
No problem. This is actually an important question. I was debating about what should I run this just in master, or should I run 3 copies to provide like replicate logs to maintain the persistence? But I feel this will hugely complicate the design. So and since we have a couple of existing frameworks for long running chat hacks, I feel we can just use that.
Yep.
And the worst case, if people just don't want to deploy that, they can run a systemd service on the master to run these things. Well, not on some agent that they are sure that they are stable enough to run this. Yeah.
But they have, if that's the case, they have to control a particular agent to run only one instance.
Yeah, maybe running a master and agent side by side on the same node, on a beefy node, and that reserve that agent to only running such controllers, not all tasks. That might be another possibility. So so we have this controller that maintain a consistent, like persistent view, the global view of the resources provided by this resource provider and perform the operations. And we have publisher that do the agent side mount, unmount, etc. And then, as I said, we need this attach and detach to make it easy for frameworks to use these external resources. We have 2 attaching workflow. The first one is called implicit resource attachment, which the framework, to simplify the API, the framework can just grab an external resource and grab an offer containing external resource, grab an offer containing local resource, and say, want to accept these 2 offers running one single test, use both the local and external resources. And then the Mesos will figure out, this resource is not, external resource is not attached to that agent, the framework to run the app on. So it will do the implicit attachment first. And but attaching or detaching resources can be expensive. So for frameworks that really want to control, take advantage of locality for attached volume, it can explicitly say, I want to attach resource and launch all tests on this resource. We will expose the agent that a particular resource is attached to. So the framework can look into that, opt in, and launch tests, schedule tests based on that information. And when they finally decide they want to move this volume to another node, they can explicitly say, I want to detach it and attach it to another node. So we support operations for explicit attachment, or just use the normal launch flow for implicit attachment.
So implicit vs explicit, are they, so which one, so they are configurable, right, by the...
Well, it's not, there's no configure there. It just, if the framework use an external resource on an agent that is not attached to, implicit attachment will happen.
Always happen.
Always happen.
So
okay.
Yeah. Okay.
maybe we can add a configuration, but I don't see there's a need for that. Yeah, because that implicit flow will not happen if the master detect, okay, they are the resource actually attached. So we have this new scheduler API to attach the data resources. We have the new offer. We need to change the offer to provide like resources from a particular resource provider, and which means we need to make this to required field become optional. And since this is unsafe, we need to have a new capability saying that only framework that register with this capability will receive such offers. And this is how basically how resources are offered to frameworks. And the others are more detailed design for resource provider. We have non-necessary changes for resource provider API. We have, okay, let me just go to here. And the way we run external resource provider will be like, so as I said, the operator or some long-running framework will launch a pod containing resource provider controller, which will be a binary. It'll be executable that specify the master URL, let's specify the ZK or maybe other persistent store. We can discuss this later, like further, to persist the global view of the resources. And a config will look like this. Like it's declared its type in name by default. If this exists by default, when you offer out the resource, what reservation should be under, and how to launch the control node plugin. Basically, the master don't need to know how to launch a control plugin because it's already in the pod. But it's just for like consistency, we will still provide this a whole info in the resource provider info and register to the master. And then I'll skip the details, but you'll see. You'll see that after the master is a really small one. After the master see some resource provider controller subscribes, it will tell all the agents, hey, there is a new resource provider subscribe. Please launch the corresponding publisher. So after the publisher launched, you can start using those resources. And okay, I also cover how the implicit explicit resource setting works here. And there are some open questions remaining in this design doc. One is the topology support, and another thing I haven't covered is how do we allocate the resources. Does it make sense to use a pessimistic model? Does it make sense to use fair sharing for external resources? These are actually still open. And this is some discussion I had with other committers about this. I list some possibilities, but how we allocate resources is actually still open, and we will follow up with probably another design to lay this out. So basically, there are other open questions so basically this is a really long design doc, and I just gave us an overview about what this is. And so please, if you have time, take a look and comment on this.
Thanks, Chenung. That is awesome.
Yeah.
Really good job on this design.
Yeah.
Do you think we could step through the user-facing API changes that are introduced here?
Sure. As I said,
so first, the attach and detach. Could you maybe go into detail on those operations?
Sure. So first of all, to support explicit attachment, both explicit and implicit, we introduce a new field in the resource proto here. So I call it attachment info. So this will be in external resources. This is optional. So if it is set, that means it's currently attached to an agent. So the framework can look at the offer they receive and see that the resource contained in that offer contains the attachment field. And in this attachment field, we have the state ID. So the framework can make a schedule decision based on the status where the resource is attached to. And and also we provide like operator offer operations called attach resource and detach resource to attach and to like do resource conversion. So they are not so these operations are unlike reserve and unreserved, where for reserve and reserve we are like kind of guaranteed we will succeed. If this doesn't succeed, it means the cluster is in a big problem. But for attach and detach, because we need to communicate through, like for example, EBS volume, we need to communicate to the AWS API and tell them to attach, and it might fail. So these are the new style operations that we introduced in 1.5, where the framework, when they issue these operations, these don't immediately take effect. So those resources will be like subtract from the pool from offering out, and wait for the result to come back, and then convert it then with convert the resource and put it back to the pool. And we will, in 1.6, we have this resource feedback. Offer operation feedback. So that will be ideal for using this kind of operations, where the framework can know if this operation succeeds or not.
So is the expected workflow for a framework that they will reserve resources before doing this stuff?
Yes, a typical workflow would be like, actually it's kind of similar to what, a typical workflow would be reserve resources and then do this like attach if you want to do explicit attachment. And
So I guess, we require that persistent volume resources be reserved before you create a volume.
Yes.
I actually don't know if that was purely for API usability or if there was some lower level technical motivation for requiring that. I don't know if you guys are aware of the motivations for that at all.
For persistent volume,
I'm just wondering if it makes sense to have a similar requirement here, if it's purely for API usability.
I don't see a requirement, like I don't. Oh, you mean just for consistency, every operation needs to be resolved?
No. Well, I'm just thinking about the framework workflow. If a framework wants to definitely get that back after the attach, then they would want to reserve it. But maybe it doesn't make sense to.
But I don't see a reason to enforce that.
Yeah, perhaps not. I was just wondering off the top of my head if we had some underlying technical motivation for the persistent volume requirement, or if it was purely for API usability. But I'm not sure.
I don't know.
Okay, yeah, that's fine.
Yeah.
Okay, cool. And so the attachment info follows the resource.
I think for persistent volume, there are multiple reasons. Like if you want to consume a persistent volume, we have to do reservation. And if G online, G might know more about those.
I'll probably sing with him.
Legacy reason. And for example, let's say a task consuming a persistent volume, it could crash anytime. And so for those tasks, we always expect we could launch it on the same agent because the data is on the agent. But I'm not sure the external volume is the same case here.
Yeah, I think my thought is probably put less restriction. And if the frameworks want to reserve it to guarantee that it comes back, we can still do that. But we can also enable the possibility that a framework just do this detach and then hand over to another framework. Yeah. Well, to hand over to another framework, we may need another reservation, but yeah.
Okay. Cool. Well, that was just a side note. Maybe we can continue looking at the public-facing API.
Yeah, and there's another thing that's for implicit.
Sorry. One more question.
Yeah, sure.
Is the attachment info new?
Yeah, it's a new prototype. Protobuf. So it's like currently we have a slave ID and,
okay.
and this internal metadata which are not supposed to be set by the user. This is carried over because it's kind of transparent to Mesos.
Okay, so the attachment info rely on labels to
no, not labels, just slave ID.
Oh, only
this is just for the plugin use.
Okay.
Yeah, we have a same field in like.
I see.
Yeah,
I see. Yep.
This is opaque to Mesos. Basically, just attach it to a slave ID, and all the scaling decision can be made based on this.
Yeah, I missed that. Sorry.
Yeah, and for the implicit flow, the framework just don't need to deal with these operations. It just, as I said, just launch a task on an agent and say I want to use this external resource, and after that launch or launch group is issued and successfully executed, the resource will also be converted. So, and after it finished, the resource will remain attached on that particular agent. So the framework can actually do implicit attachment through launching a task first, and then start to look at, okay, this resource is already attached on this agent. I can continue to launch this task on the same agent. They are free to do that.
Okay.
Yeah. And this is, yeah, please.
So it just occurred to me. So we have this framework capability.
Mm-hmm.
I'm wondering, would it be possible for a framework without the capability to use the implicit workflow?
Well, without capability, you will not receive external resources. So
and that's because of the optional agent.
Yeah.
Huh.
Right.
Okay. Yeah, that makes sense. Never mind.
Yeah. So you don't need to worry about that at all.
Okay.
And the second the user-facing changes, as I said, we have change the offer, make it optional, and introducing capability, and that's it.
So also, I guess an operator-facing change would be configuration of the SERP controller. Is that accurate?
Yes. So this one, you either run this through like long-running framework maintaining task like Marathon. You can launch a Marathon app that run this controller and setting this configuration and yeah.
Okay, so the JSON you show here is an example for the config flag?
Yeah, right.
Okay.
Or we can change it to like store in somewhere in disk and then just load it.
Sure. So default reservations, does that mean that by default or what does that mean? Sorry.
Okay, so this is optional. So if it is not set, then all the resource reported by this SERP will remain unreserved and served will be offered to an arbitrary framework based on the allocation result. If it is default reserved, then the only frameworks that subscribe with the roles will receive those offers.
What does it mean to specify the type of a default reservation? That seems a little strange to me.
Well, it's just we're just using the new reservation refinement format, which requires a type and type become static or dynamic. I just want to make it consistent.
Yeah. Okay.
Yeah.
Okay, and what else is in the config? So this is all plugin specific stuff.
Yeah.
Okay. Can you help me understand so we have a storage field in the SERP. So the SERP controller is generically useful for any type of external resource?
No, SERP SERP controller will be a binary that's used specifically for CSI, but In general, ERP design and the resource provider info will be generic to all external resource provider. So that's why in 1.5 we have a specific field for storage that to deliver the CSI specific configurations. And in the future, if you want to support things like TBU and other things, we will have like other optional fields for their specific information.
So, okay. So, I mean, so we have an SERP controller, will we need to add new controller binaries to support new external resources in the future?
You mean other than storage resources?
Yeah.
I would believe so. Yeah.
Okay.
Because those need to support, like, you need to dedicate like binary to support non-storage operations. Maybe in the future you want to provide.
Okay.
So we need to support common operations like reserve on reserve. But for example, if we want to support like IP pools, it doesn't make sense to support create, right?
Yeah. Uh-huh. Okay. So one of the open questions was the topology question.
Yes.
Would that be going in this SERP config? Is that where topology information would potentially go?
No. So the topology concept introduced in CSI is that each CSI plugin will have its own topology information. So, and they may not be like consistent with each other. Like for example, if we have node ABC, like for plugin X, maybe AB is in the same zone, C is not. For plugin Y, maybe A is zone and BC is in the same zone. So, and because it really depends on how the storage backend works. So that's why the CSI plugin have this flexibility, and it doesn't necessarily match to the Mesos domain, the concept of Mesos domain. So a probable implementation is that the publisher, where runs on the node, is the one that will run the CSI plugin and get the information, because sometimes those topology information can only be obtained from the node. You cannot obtain from the controller. So that's the publisher will obtain the topology information through the plugin, and then dynamically add new attributes to the agents. The agent can update the attributes through the update state message. I haven't introduced that yet, but we can extend the update state to do that. And after those attributes are exposed to the master, and then those attributes will be put in the offers, so the frameworks will be aware of the topology for each individual agents when they receive their offer. And there are two options we can do here. We can make the framework just not aware of the topology at all, and the allocator to deal with those when they're doing allocation. Or we can reveal those information to the framework, so framework can do some of their customized like scheduling decision based on the topology, and it is still kind of open. And it will not be in the MVP for this project. So I'm just mentioning a couple possibilities that to support this.
Okay. Yeah, I think this is one of the tricky questions yet to answer. I would be curious if anybody on the line has any thoughts on how we should handle topology awareness with external volumes. Anybody?
We should use attributes. That's my thoughts.
Uh-huh.
Oh, gee, you're here.
Yeah, I'm here. So I think for topology, like agent should expose. I mean, agent already have those agent attributes. I think a natural way to extend that is to allow additional attributes to be added, which is related to topology. Like for example, you have an attribute called zone, column, something, or even some plugin specific attributes for because the plugin, like for example, the CSI plugin's topology requirement might be different than the topology information might be different than orchestrations like those topology definition. So and I think using attributes is an easier way to like say, hey, just label those attributes. Just label the agent with those attributes that's related to topology, and then in the allocator do a simple like a string matching, trying to figure out whether this resources have this whether this global resource can be accessed by in a given agent by just looking at those attributes and do a simple like set intersection, something like this.
So in that case, do we expect the framework to figure out what volume can be used on what agent based on the label or based on the?
Yeah, we need to publish that algorithm to the framework. They have to use the same thing to do matching to decide if it's okay to use the resource on a particular agent with certain attributes.
I actually feel that we may move part of the logic into allocator. But it will complicate allocator design. Like we already have a like DIF algorithm with quota and other things. We already have like two-phase allocation. I'm not sure what complexity you will bring to allocator if we put the topology like awareness into allocator. So this is not like this is still design still.
Yeah. I think the trade-off of that is the complexity of the allocator compared to just have the logic. I think the trade-off, is like if you have the logic not inside the allocator, all the framework have to implement that logic to do a matching.
Yeah,
I think that's what they do already. Like especially for things like they have all these constraint support already. Like if you look at Marathon constraint or SDK constraint, they all have such support already. I don't think that it's gonna take too long for them to adapt to this new thing. Just additional constraints to me.
Okay, well, I want to make sure we leave time for the second item on the agenda. So I would propose that we leave it here. I think the topology question is a good one. I would definitely encourage people to comment on the doc if they have any ideas on that score. Would anybody else like to add anything more before we move on? No? Okay. Thanks so much for that proposal, John.
Sure.
It's a really great design. Appreciate it. So the second item on the agenda is the minimum allocatable resources. It's something that Meng has been working on recently. Unfortunately, I believe he had a conflict during this time today, so he wasn't able to join. But I've been working on it with him, so I could speak to that. Here, let me share my screen, maybe. He sent an email out on the dev list. Okay. Cool.
Actually, I have a link in to the thread.
Yeah.
The work group doc.
Cool. Thank you for adding that.
Oh, but this is not rich format. If you want to look at like the fancy like rich format text, probably.
Oh, that's okay. So yeah, we wanted to allow operators to configure precisely how a given set of resources is deemed allocatable or not. Currently, it's just hard-coded in the allocator. So we were proposing a master flag that would allow someone to configure this. Somebody brought up, Alex R. proposed perhaps an API call to do it dynamically. And G, I know that you had suggested thinking ahead to the possibility of adding a per framework refinement of this allocatable specification. So you were suggesting perhaps adding new protobufs. And I think that seems like a pretty good idea to me. Perhaps the resource protobuf isn't very well suited for this particular purpose, since all we really want is the resource name and some scalar quantity. So I think I'm generally in support of thinking ahead to that API and making this work with it. What I might suggest is that we don't add all of the protos for a full API now, but just add what we need in order to specify a master flag. What do you think?
Yeah, I think that sounds fine. Just not adding everything for now, but I think I do want the protobuf design to be in such a way that it can be extended to what we want to do in the future without any breaking change.
Yeah, I guess so. So you're actually thinking about how we would implement the request call.
I think to me these are the same thing, because it's the allocatable thing, and the request is basically some kind of filter that you tell the allocator about resource allocation. Like, just think about allocatable thing is a global filter that you want to apply on a given framework if we were to do this for per framework. Like, don't send me any resources that's below this minimum amount. To me, it's like a special filter, right? We have the filter now. This one is just like a special global filter. I feel like we should have, for those kind of filters thing, I mean, I think for resource requests, it's like a filter. Well, it's probably not a filter, but some sort of like, it's kind of related to filter. Like some of the requirement on the resource that you just need to satisfy in the allocator.
And for the global filter on the master, I kind of think that a flag is sufficient rather than a master API call.
I think, okay, you're talking about, that's the other ones, and that's the Alex Sar's comments.
Yeah.
Okay. I think for that one, I don't have a strong opinion. I think we can start with flag. Maybe we can do both in the future.
Mm-hmm.
Yeah, I think the master API, the only benefit is you can do dynamically updating that thing. But I imagine like it should be pretty rare when people wants to modify this config.
Yeah.
And if we have the per framework API to allow each framework to tune their minimal allocatable resources, then like the requirement for the master flag, the master API, it's kind of weak, right? If the framework has per framework control, then we don't really need that master API to tune the global knob.
Yeah, I guess the benefit might be that the global setting would allow operators to improve their allocation even for frameworks that haven't implemented the request call.
Sorry, why is it related to the request call?
Well, so what I heard was that you were just suggesting that once we implement request, that the global master setting wouldn't be very necessary. Is that accurate?
Yeah, I think we're talking about the minimal allocatable flag, not the request. I haven't thought about if it's necessary to have the master API for request.
Okay, I guess, sorry, maybe I'm confused.
Yeah, so the request is like when the framework asks Mesos, say, hey, I want, it's pretty much like a limit. Like, I think we might want to treat that as a limit, like say, don't send me more than the requested resources to me, because that's all I requested. I might have some guarantee using quota on my role, but I don't want the limit to be, I don't want the resource to be unlimited. Like I do want to throttle the allocator to only send me up to a given limit.
I mean, from the framework's perspective, the thing that's most useful is the requirement, not the limit, right?
For require, you can use quota. Why do you need to use request?
Well, so current quota does not specify the shape of the offers at all, which is one of the big issues.
Yeah, but I think we should improve that API, the quota API, to support the shape of the resources rather than using request. To me, request is like a limit.
Well, I mean, quota is going to be both a guarantee and a limit.
But we're gonna separate these two. Oh, I see. So you're saying like.
Right. I think that's been Ben Mahler's intention.
Yeah, that's true. So once we have quota, both guarantee and limit, why do we need request?
Yeah, I think that's a good question.
So yeah, in that world, I feel like request is more like telling what is what is the shape as suggested by Greg. What kind of resource do I need? It's not about the amount of resources.
We can have shape support inside quota.
Yeah, I think it could be that we only need one of these interfaces, quota or request.
I guess maybe in that case, if someone, let's assume some firm don't set quota on both guarantee or limits, or one of them, is there a way to give some hint to the allocator? I guess it doesn't make sense.
Sorry, what do you mean? Give something to the allocator?
Give some hint to the allocator. Like request is more like I have a hint for you. Yeah, it kind of doesn't make sense. I assume like in the world of like when quota have get both guarantee and limit, like you probably don't need this request thing. And I think it's a better way to just make the quota support like resource shape.
Well, and currently quota is only in the operator API. Is that correct?
Yeah, that's correct. But I don't see a reason why this cannot be a framework API.
Yeah. And I guess so maybe it's not stated explicitly anywhere, but it seems to me like, so quota is per role. Something being like having a request call in the scheduler API kind of implies to me that it would be an action that's per framework, or maybe per role per framework. So if we did add like a set quota call to the framework API, would that set quota for the entire role? Or maybe that does make sense. I don't know.
I don't think we should introduce like framework level quota. I think like quota should be, I mean, all the resource allocation related stuff should be corresponding to a role, not like an individual framework.
Yeah, I feel like the quota in general are the concept that the operator should control, not a framework or an app should control.
Well, you can think of framework as an operator too.
Yeah, sure, but
it can hit master API. Yeah, I think the boundary between scheduler API and the master API is blurred. Like what's the criteria? I mean, I think the fact that we split scheduler API and the master API is kind of a little weird to me.
Yeah, I think so.
Maybe these two can be combined to just like, hey, Mesos API.
However, I definitely think there will be cases where multiple frameworks are registered in one role, and frameworks would like to tell the allocator what they want without making some claim for the entire role, but just for that single framework. So I feel like the interface should accommodate that scenario.
But in that case, essentially you want to have some separate allocation policy under a given role, then you should have sub role under the top level role, and for those frameworks to register in the different roles.
Yeah, perhaps so. Okay, well, I guess so we were hoping to implement something for this global minimum allocatable resources setting in the not too distant future. So my hope would be that we can come up with something that we think won't constrain us too much in the future when we implement request and or chunked quota without going too deep into the implementation specifics of that feature.
Yeah, I think that sounds good. Like I just want like this to be future looking, not just for the current issue.
Yeah, I
Because
think that's a good
otherwise
idea.
breaking an API is not a good thing.
Yeah. So maybe I could make it an action item for myself to set up a meeting. I could blast out an email on that chain, on that thread, ask if there are other interested parties. I could set up a meeting for us to talk a little bit about this.
Yeah, that would be great. Like collecting more feedback on this will be useful. Because I think the example I give here is not ideal either. I think it didn't consider like something like attributes, agent attributes. That we do have a use case for that in the future for things like, for example, I do want to get some resource of a given resource provider, or I want to request quota. Like I want to set quota on a given resource provider resource, like resource of a given resource provider, not a given name. Name is like the type of resource, but you have some for the same type like disk, you have different resource provider providing the resources, and maybe I want to set quota on different resource provider resources. So things like this, and also like attributes. I haven't thought about that yet, but this might be related to that too. I think it's worth spending some time, like maybe one day, thinking about this API ahead of time, so that we don't go back and change our API and break our API later. But I agree that we should not get too complicated. We don't have to implement all these. Just leave the option open so that we can add that later.
Yeah, that sounds good to me. I'll set up a meeting. Okay, does anybody else have any comments on that, that point? Nope. Okay. Well, that's all we had on the agenda. Did anybody else want to bring up some last minute items before we end today? Anything? No? Okay. Well, thanks for joining, everybody. Appreciate it. Thanks for presenting, Chun Hung. Would encourage everyone to take a look at that design doc and comment on it. And I will send out an email about this minimum allocatable resources discussion. And we'll see you in a couple weeks next time. Thanks, guys.
Thank you.
See you.
Bye.
Bye.
Thanks, Greg.